Find the sum of the following series. You have from article 1 to infinity of 2 divided by 8 to the power of 3r. I've worked this out already, and my answer that I got was 2 divided by 511. Now, that's what you should get to if, of course, you did not make a mistake. So I want you to pause the video and work it out and see if you get that. Alright, you're finished. Let's look at it. The question, first of all, is what kind of series is this? Is it an arithmetic progression or a geometric progression? Well, if you're finding the sum to infinity, that is implying that it is a geometric progression that is convergent. That means the next number is smaller and it keeps getting smaller and smaller. So the sum to infinity reaches a set number. Alright? Now, of course, we have other ways to find that out, but just looking at the question, you can bet it is a geometric progression. But let's see something here. What happens when r equals 1, r equals 2, r equals 3? When r is 1, you have 2 divided by 8 to the power of 3. Right? When r is 2, you have 2 divided by 8 to the power of 3, 2, 6. When r is 3, you have 2 divided by 8 to the power of 3, 3 is 9, which would be some big numbers. But if it was an arithmetic progression, well, it wouldn't be an arithmetic progression because you'd be saying that 2 over 8 to the 9 minus 2 over 8 to the 6 is the same as 2 over 8 to the power of 6 minus 2 over 8 to the power of 3. Right? I don't think that would work. Remember, this number is 10 times bigger than this number. And this number is 10 times bigger than this number. And it's 8 to the power of. So, you'll be saying that if you find 8 to the 9, it would be a very large number, right? In fact, you could try it with a calculator and say 2 divided by, let me use bracket just for safety, 8 to the power of 9 close bracket equal, very small, minus 2 to the power of 8 to the 6 minus open bracket, or 2 over 8 to the power of 6 close bracket equal negative that. But if you have this number minus this one, 2 over 8 to the 6, 2 over 8 to the power of 6 minus 2 over 8 to the 3, 2 over 8 to the power of 3, you get something different, showing that it would not be an arithmetic progression, right? Alright. It would be a geometric progression. Now, here, you know that the sum of a geometric progression of sum of n terms of a geometric progression is a over 1 minus r. You should try and remember that, just in case you're not given a formula sheet for it. When it's not the sum to infinity, it's really a long drawn out formula, same as for the arithmetic progression for the sum. And I would suggest a formula sheet for that, right? Instead of trying to test your ability to remember that long formula. But for the sum to infinity is a over 1 minus r. Easier to remember that one. Now, oh, so let me note here, not an arithmetic progression, or it's not an arithmetic series, right? Now, you need to know A and R. Now, what is A? A would be the first term. A would be R when R is 1, so it's 2 over 8 to the power of 3. So A is 2 over 8 to the power of 3, right? What is R? R would be this term divided by the term before it. So in finding R, you would say it's 2 over 8 to the 6 divided by, it's 2 over 8 to the 6 divided by 2 over 8 to the 3. Alright? Same as 2 divided by 8 to the 6 multiplied by 8 to the 3 over 2. So here you have 2 cancel 2. So it's 8 to the 3 over 8 to the 6, which would be, when you cancel them out, you subtract them, right? This would be 1 over 8 to the power of 3. That's the common ratio. You could use this as well, right? The same thing would happen if you say 2 divided by 8 to the 9, and all of that is divided by 2 divided by 8 to the 6. You get the same thing. So you see it would be a geometric series, geometric progression. Alright, so the sum to infinity would be equal to, oh, you know, I had put Sn. It should be S infinity here, not Sn. Alright, for Sn it would be that long drawn out formula, which is more complicated than this and harder to remember, right? But it's sum to infinity equal a over 1 minus r. So this sum to infinity would be a, which is 2 divided by a to the 3 over 1 minus r. R is 1 over a to the 3. Right? Now, this would be, if you consider it like this, 2 divided by a to the 3 all over. 1 is 1 over 1. And it's the same as a to the 3 over a to the 3. Just getting common denominators here. Right? Minus 1 over a to the 3. This would be 2 divided by a to the 3 all over. Well, it's something over a to the 3. It's a to the 3 minus 1. Right? So sum to infinity of this thing, it would be the same as 2 over a to the 3 multiplied by a to the 3 over a to the 3 minus 1. A to the 3 would cancel a to the 3, right? So what you have is 2 divided by a to the 3 minus 1, which is 2 over something minus 1. What is that thing? A to the 3. What is 8 to the power of 3? 8 to the power of 3 equals 512. So it's 512 minus 1. So the sum to infinity is equal to 2 divided by 511. Alright, so did you get that? If not, I'm going to ask you to write the question down, pause or stop the video, and work it out without looking back at the video or any other solution. Alright, so that's it for now. I'll see you in the next video.